Hey guys, today we're looking at P.4, which is about polynomials. So the definition of a polynomial is pretty simple. It's written up here, but it's just an x to the n plus an minus 1 x to the n minus 1 and so on to get to a1x plus a naught. So all these an's, an minus 1, so on down to a1 and a naught, those are all just real numbers, and then we multiply by some variable raised to an exponent. And whatever this n is, which is the biggest exponent that you have for your variable, that's called the degree of the polynomial. And we have a couple special cases. The degree is 1, it's called a linear polynomial. Degree is 2, it's a quadratic polynomial. And the degree is 3, then it's a cubic polynomial. So the definition is not too bad. Just a string of coefficients with x or any variable raised to some power. Alright, one thing we'll do a lot is call a polynomial by a name. So here maybe we'll call p equal to 2x plus 1. Alright, so we're just calling this polynomial 2x plus 1 p, so whenever maybe we want to reference this a lot, we can just say p rather than the whole polynomial. But something that's more common, instead of just using p, we'll use p of x. So again, we'll just call it 2x plus 1. But this p of x notation is a lot more useful, because say now I want to plug in a value for this x, I just do this. So say I want to plug in 2 for x, here I'd have to say to the side plug in 2 for x. Here I just say p of 2. And this automatically means that whatever's in the parentheses here, I'm going to plug in for x in the polynomial that I set it equal to. So here, I know p of x is 2x plus 1, so if I want p of 2, I'm just going to replace the x with this 2. So now I have 2 times 2 plus 1, so my final answer would be 5. And I can pretty much plug in anything in the parentheses here. I could plug in just another number, p of 4, which would be 2. Again, I'm replacing the x with the 4 plus 1, which would give me 9. Or I could even plug it in with different variables. So say I know something else about a and b, and I might want to replace my one variable with something else. Alright, well then again, I'll just plug in whatever is in the parentheses in for this x. So I get 2a plus b here, plus 1. Alright, so if you wanted to expand that, it'd be 2a plus 2b plus 1. Alright, so this notation is a lot more common where we actually have the p of x rather than just the letter. Alright, and that helps us plug in things later like I did here. Alright, moving on. Sometimes I want to add or subtract polynomials from each other. So here we want to subtract this second polynomial here from this first polynomial. So we want to x squared minus 5x and then subtract this polynomial here. So the way we're going to do that, I'm going to write it. So we want x squared minus 5x. And then from that, I want to subtract this first one. So I want to subtract, and here's where it's important to use parentheses. So I'm going to subtract the whole polynomial 3x squared minus 4x minus 1. Alright, and it's important here that we're going to use parentheses because when we do this minus, this negative is going to distribute into whole polynomial. So the next step, we saw this x squared minus 5x. Alright, now this negative, like I just said, is going to distribute in here. So we have a minus 3x squared, negative, and negative here, giving me a positive 4x and a positive 1. So a mistake a lot of people will make is just put minus without the parentheses, and they'll have the minus 3x squared right, but then they'll still have a minus 4x and a minus 1 when this negative distributes and gives you a plus 4x and a plus 1. So now, of course, to simplify, we just combine like terms. We have an x squared and a minus 3x squared. That leaves with a minus 2x squared. We have a negative 5x and a positive 4x. I guess that's a negative x. And our only constant term is the plus 1. Just make sure when you're subtracting one polynomial from another, you distribute the negative into the entire second polynomial. Alright, now something that's a little bit more difficult is multiplying polynomials. This first one, we have one binomial, which is a polynomial with only two terms. So we just have these two terms, a plus b, and these two terms, c plus d. It's a special way to do that. We call it FOIL. Alright, so FOIL stands for first, outer, inner, last. So what we're going to do is multiply the first term. So we're going to do a times c. This is going to be our first one. Alright, so that's our f. Our outer, let me label the f. Alright, the next is outer. So a is on the outside of this one, and d is on the outside of this one. Alright, so now we have a, d. Alright, next is inner. So b and c are on the inside. So that gives us BC. And the last is the last one in each one. So we'll use gray. And we take this b is the last one in the first binomial, d is the last one in the second binomial, so we get bd. Alright, so this will work for any two binomials. Just multiply the first two, so a times c, the outer ones, a times d, inner b times c, and then last b times d. So just make sure you FOIL whenever you have two binomials. And now the very last one, this will also work for two binomials, but that's just a special case. But if you want to expand this, what we're going to do is think about the distribution property. So instead of thinking about this as an entire polynomial, we're going to think about it as a single term. So remember, we have the distribution property that says if we have a times b plus c, we get ab plus ac. Alright, we're going to use that to our advantage here. So we're going to think about this 2x minus 3 as our entire a. So we're going to distribute it into each piece here. So we're going to get 2x minus 3. Alright, that's going to distribute into our x squared. Alright, again, 2x minus 3. Distribute it into the 3x. And then 2x minus 3 distributes into the 4. Alright, so we just distribute this whole piece here in each one of these individual pieces. You could do the same thing up here and you'd get the same result, but it's just easier to remember FOIL for these two binomials. Alright, so now we want to keep simplifying. Well, now we have to do distribution again. This x squared is going to distribute into the 2x minus 3. So x squared times 2x is 2x cubed, and this is minus 3x squared. Alright. Here again we have a minus, so let's keep everything after it in parentheses. So everything in here is going to be in parentheses. So it's 3x is going to be 6x squared minus 9x. So again, always be careful with negatives. It might be easier for you to distribute this negative in here first and then distribute the 3x. I did the 3x first and now I have to do the negative. Alright, whichever one you prefer. And then lastly, this 4 is going to distribute, give me 8x minus 12. Alright, so before I start combining like terms, I'm going to distribute this negative like I said earlier. So now I have a minus 6x squared plus 9x and then plus 8x minus 12. So this plus 9x might be something a lot of people will miss because they'll go straight from this step and put minus 6x squared minus 9x and not remember that this minus is going to distribute into this whole piece of the polynomial. So that's why it might be easier for some people to distribute the negative into this first one first, or think about this as negative 3x times this piece too. So there's a bunch of different ways. Just make sure you're careful with your parentheses. Alright, now the last step is to combine like terms. So this first term is the only one with x cubed, so it's going to stay by itself. Alright, I have negative 3x squared and negative 6x squared will give me a negative 9x squared. I have a positive 9x and a positive 8x, so I give me a positive 17x. And then the only constant term I have is that negative 12 at the end. Alright, so polynomials for now aren't too difficult. Just remember, if you have this p of x notation and I'll put in some value inside the parentheses, so it just means replace all the x's in the polynomial with that value. Alright, and then the only really other important thing for this section is be careful with negatives. So when we subtract one polynomial from another, the negative needs to distribute into the whole second polynomial. Same thing down here that we had with this 6x squared minus 9x. This minus is out in front of the polynomial, so make sure it distributes into each piece there.